Hello, today we'll be talking about controls and environmental design. In terms of the design of controls, we must avoid reading errors. We can use either analog or digital controllers to improve the operation in order to not have errors in the reading of the controls. Here are some examples of good and bad designs. For example, this is a copy machine where the colors don't mean anything. For example, a light blue or a light green or a light yellow doesn't tell you anything. For example, this light green, maybe we will assume that as it is green, it is the one that you need to push to make a copy, and that is not. The copy it's in the yellow. And this is when you need to stop the copying process because something went wrong. So maybe you should choose different colors such as green for the copy one and red for the error button. There are some consideration in ergonomic text and displays. For example, the superior border should be at the height of your eyes. You as an operator, if you are working with a control or a screen, you should be at some 50 to 60 centimeters from it. The place should always be illuminated. The character height should be between 3.5 and 4.5 millimeters. You as an operator must be able to modify the luminosity and the contrast between your control and you. You should never be in front or to the back of the windows because of you'll have a lot of illumination and that will not allow you to see the characters in the screen or in the control correctly. And you should have a nice relation of contrast between the, the the bottom of your control and your characters. So it is recommended that the screen it's a light color and the characters are dark color. For example, the screen is white and the characters are black. Here are some types of controls, and some of them gives you more or less control. There is some aspect to be considered, such as space compatibility, that the controls, the screen and the control are distributed in a way that you understand which control moves each screen. For example, on the left, you can tell which of the buttons control which of the controls. Maybe we can be sure that this one on the left works with this control, but the other five, you're not very sure of what they control. In this case, as they are distributed kind of the screens, you can tell which control you should move to increase or decrease the variable that you are trying to control. Here are some other examples of good and bad designs. This is a bad design because you have to put your arms through the machine so it can work. And here, this is an oven. And here, you are not in risk of having of burning. In this case, the controls and what they are controlling physically, they're not distributed correctly. These buttons here operates this part of the machine, and these buttons operate this part of the machine. This is a recorder. There should also have movement compatibility. So when you move your control to the left, the control moves to the left. If you move it to the right, the control moves to the right. Temporal compatibility means that the time that it takes you to move the control should be the same as the movement in the control. If you that you are seeing that as you are moving your control, the display is moving also. Now let's talk a little bit about standing posture and its activity. What are the heights of your table, of your work area recommended for different types of activities? If you need precision, the height of the table should be between 95 and 120 centimeters. If it's a light workload, the height of the table can be from 85 to 110. If you need to apply some force to what you're doing, such as cutting meat, the distance should be between 65 and 95, so you can use your back as a force. When we are handling loads, we must always mind your spine. So you don't want to compress your spine when lifting some kind of load. And there are some ways to do the lifting. So you should bend with your knees bended, and then use your back to lift the charge. You should consider that if you are doing it wrong, such as in the example, even though you are trying to lift 25 kilograms, your back is going to feel a force of 375 kilograms. So you are risking a lesion in your spine. But if you bend your knees, then the charge in your back, in your spine, it's going to be 3 times only. That it's a lot, but you can have that charge in your spine without any trouble. When you are analyzing a lifting method, first of all, you need to plan the lift. You must examine the load charge. You should have a route, a path that you are going to follow, having the load chart. You should use clothes and shoes that are according to the activity, and you should ask for help in case of an excessive charge, and maybe not getting help, but design it the activity for 2 or more operators. You should mind your feet. You should have a distance of 50 centimeters between them, and they should be according to your upper body. Here are some examples of lifting methods, and you must always try to avoid moving your body to one side or the other when you are lifting. You should have a stable position with the charge in front of you. Here are some examples of good and bad positions when sitting, when trying to move something, when trying to lift something. When you are applying force, maybe you should use a step. And again, we are looking at some bad and good positions for lifting a charge. Look, always close to your body. And this is other positions, not for work design, but they are useful. Well, let's talk about tools. This also applies with them. And it is better to have it close to you so you can use them when needed and not be used when not. Now, we are going to talk about environment. It is very important. The first thing that we are going to analyze, it's noise. According to the type of work, you should, first of all, measure the decibels of that noise. And in this graph, we can see the dangers of high levels, high decibels in noise. If they are up to 110 decibels, you have the risk of getting death. We can lower it down to 30 decibels. That would be the minimum that you should design to. In terms of lighting, that it's another factor such as noise. We must consider the operator, the task, and the lighting. All of them interact so we can have a good quality of vision in the environment, and that get us to effectiveness in the process performance and to have a secure ambience. We must mind the lighting level, the amount of light that hits the surface, and it is measured in luxes. We must also consider luminance and brightness, that it's the light that it's reflected from the surface. So lighting level, it's the amount of light that hits the surface, and luminance, it's the amount of light that the surface gives you back. Here are some lighting levels according to the activities. If there are some low visual demands, you have some 100 luxes. If you need moderate visual demands, 200. If there are very high visual requirement, you must go up to 1,000. In terms of luminance, we must consider the radio of luminance of any adjacent area in the visual field. And this is to avoid reflexes and adaptation problems. So you are performing your activity in a safe manner, and the reflection of light that comes from the furniture, the ceilings, the floors, doesn't distract you from the activity that you are performing. There are 3 different types of lighting: general lighting, localized area in general, or localized for a specific task. For example, in our office area, we can use general lighting. If you are doing a specific task, such as a design, you must use localized. And in the work area, in the workstation, you can use localized area, so you illuminate your equipment, your machine specifically. In terms of thermal environment, you should look into the air temperature, the type of activity, the air humidity, the type of clothes, the air velocity, and the mean radiant temperature. We must also take into account the acclimatization of the body. And in that terms, we must mind the number of pulses per minute, the cardiac rhythm, the sweating, and the internal temperature. If you are not exposed to heat, your internal temperature shouldn't go up from 37.8. There are also some psychosocial risk factors that we must mind. Organizationally, we must analyze the organization of work and the processes, the worker conditions and environments, and the communications. Individually, we must search for pathologies, we must analyze personality and private relations, because these two main factors can prevent each other to work in a correct manner and be efficient at work. For example, there are some psychosocial risk indicators, such as socioeconomics or preventive. In socioeconomics, we can observe absenteeism, the annual hours worked, atypical hours, rotation rate, temporary workers, judicial processes, structural changes, and the organization of work. And as preventive, we want to prevent work accidents, professional diseases, work diseases, stress cases, bullying, and violence. In terms of consequences from stress, for example, we must work into moral harassment, busing model, the burnout syndrome. And how should we intervene in these types of, when we find one of those cases? First of all, we must obtain management support, then arrange some human resources committed or talent committees and management support. We must establish the manager's responsibilities. We also must establish a pilot committee, a group of persons that are going to be analyzing those aspects. Define the methodology that we are going to choose and that we are going to follow. Then we are going to analyze the information from that we gathered from applying that methodology, such as collecting the information about the consequence of stress. We must identify risk factors. We will analyze the collected data, identify solution, pilot implementations, implant solutions, and at the end, we are going to monitor and evaluate all the actions that we implement. We can use quantitative or qualitative methods to gather the information. And this will be it for this part of an topic. In the next video, we'll be talking about the evaluation of ergonomics.